Welcome. Now we will be discussing the rules of differentiation. So this is actually going to be pretty quick. So firstly, if you're adding two terms, right, and you're supposed to differentiate the sum of the two terms, it is the same as differentiating each term, right, that you're going to add. So we call that the sum rules. So you are allowed to say, to split this up and differentiate them by their own. And the same thing applies for the difference rule, right? When you're subtracting terms, you are allowed to, differentiate each term. So if you're adding and subtracting terms, you're allowed to differentiate them separately. Now, this is just the general power rule. I feel like you all are familiar with this one. It's the fact that if, let's say, we have a, x, n, and we're deriving with respect to x, so x is our variable here, and a is a constant. Therefore, we're going to say n times a, and then that's going to be equivalent to x, n minus 1. So that is what we call the general power rule. So I'm going to give you two that might come in useful, might not, but I know you're supposed to know them. And that is, if you differentiate sine x, that is equivalent to cos x. If you differentiate cos x, it is equivalent to the negative of sine x. So, add these to your, to that part in your brain, that small part in your brain, that's for, miscellaneous stuff. But stuff you need to remember nonetheless, because you don't know, maybe it'll come useful. But one thing I want to emphasize is the fact that you in grade 12 will not differentiate logarithmic, what's going on, I don't know, or exponential functions. You will not be deriving these in grade 12. So those are the ones where it's like 2, let's say f at x equals to like 2x, where x is the exponent. You will not be deriving such formulas in grade 12. So already this is everything you need to know. You need to know to use the sum rule and the difference rule. And you also need to know whatever function you're given, never start deriving a function the moment you get it. You must first simplify a function and then you can derive a function. And you cannot be dividing and multiplying. Those are different rules, and do not assume that's the same thing as here. You don't just say, the derivative of this and then the derivative of that multiplied. If you're dealing with the product rule, it has its own formula. You don't need to know it, but you need to know that they don't expect you to know it. So you need to play with the algebra a bit. So let's get into some examples. Hi guys, so I didn't see that I was not recording, so I've erased some things, but I guess I couldn't do a good job at it. So let's just get into this again. But it's the first time for you, but it's the second time for me. When you start deriving, you want to check off a list. And one of the first important things you want to see is my formula, before I start deriving, is it what I want? Is it standard? How do you see if it's standard? Are we adding or multiplying? Are we adding or subtracting? Yes, we are adding or subtracting. Tick. Are we not multiplying and dividing? That's the big one. Are we not multiplying and dividing? If we are not doing that, tick it again. Tick. We can start deriving. So if you see where you are multiplying or dividing, fix it. And most importantly, you want your x's, you don't want them in a square root, you don't want them as a denominator, you don't want them as a numerator and then something's under. You want everything to look proper. So let's start. Why is my phone saying it's low? Okay, sorry. So let's start. We're deriving this formula first. Why? Okay, are we good? Yes, we're good. Okay, so the first thing we can see here is sine. We first derive everything, so we're saying the derivative with respect to x of sine x plus 2x to the power 4. We use which rule? The sum rule, because we're adding. So the sum rule tells us what? the derivative with respect to x of sine x plus the derivative with respect to x of 2x4. You're allowed to separate them like this. The sine rule states that. What is the derivative of x squared? No. What is the derivative of sine x? That would be cos x. What is the derivative of 2 sine, what is this? Quad? 2 sine quad? 2 sine to the 2x to the power of 4. Sorry if I'm misspeaking. Clearly the day has been long. So we know we're going to use which rule? We're going to use the power rule. We're going to say 4 times 2, which is 8, right? And then we're going to say 4 minus 1, which is 3. So there you go. We did something, guys. Now we move on to our next one. Let's see. Are we adding? Yes. Are we adding or multiplying? Yes. We're not dividing or... Oh my word, I misspoke. Okay, guys, I came back from a little break. We're back in business. Clearly, the day has been long again. So, let me take my time. Are we adding or subtracting? Yes, we are adding or subtracting. Are we multiplying or dividing? No, we are not. That is a good thing. We do not want to multiply or divide, right? Are all of my x's standing alone over the power of 1, right? Are they being just standing normally? Yes, they are. There's no root, there's nothing. So we can just start deriving. So you have x, right? The derivative with respect to x, 2x squared plus 3x plus 10. Perfect. Equals to the derivative with respect to x of 2x squared, right? Plus 3x, right? No, sorry. Oh, such a nice piece of paper. I feel like people with OCD, this is not going to be a good thing to watch. X, right? Plus, right? 3x plus the derivative with respect to x of 10. A rule I don't think I forgot, but I don't think it's necessary to say, but you know, some people might not know. A constant, which means just a singular number, has no derivative, right? It's 0. It's not even, yeah, it's 0. The derivative of a constant is 0 because it's derivatives, basically it's the rate of change of something. So if I was to graph this 10, you graph this 10, you just, let's say this is 10 up here. This is the function. It cuts at 10. This is the function of 10. But the function of 3x could be something, I don't know, something like this, right? This is a parabola. This could be something like this, right? So if we're going to derive them all of them can be graphed out, right, on a Cartesian plane. This has a rate of change. This has a rate of change. This is constant the whole time. It's never changing. So there is no rate of change of a constant number. So the more you know, right? And then here we're going to have 2 times 2, which is 4. We're using the power rule once again. 2 minus 1 is 1, right? Plus 1, right, times 3 is 3. And then 1 minus 1 is 0. And anything to the power 0 is 1. So this would be 3 times 1, which is the same as 3. And then we know the derivative of a constant is 0. So let's not write it. And there you go. So we're doing the same thing. Derivative with respect to... I'm just going to jump into deriving everything separately. Actually, let me not do that. Let's do this properly. Negative 10, 3 plus 7x plus 7. The derivative with respect to x of negative 10x, right? Plus the derivative with respect to x of 7x. And I'm not going to write the 7 one because we know it's 0. You can, okay, let me write it. I want people to understand. So we know here the derivative of this, what are we going to have to do? The power rule. Oh, this is to the power of 3, by the way. So 3 times negative 10 would be negative 30. X 3 minus 1 would be 2. Oops. Okay, just wanted to fix out the zooming in, zooming out issue. But then we get to this 7x. This is 1 again. 1 times 7 is 7. 1 minus 1, 0. X to the power of 0 is 1, so we just leave it as 7. And then 7 is a constant in there, so a constant's derivative is 0. This is the one I wanted to do with you guys, the one I thought was important to do. We don't like this. We don't like this for a lot of reasons, but we don't like this. We want everything to be nice and neat and in a standard, beautiful way. And this is very confusing. So what can we do to make it less confusing? Simple. What we can do to make it less confusing is to make the x's stand on their own, right? So let's take this, for example. Let me just go under here. There's no need. Y equals to, let's take this for example, 1 over the square root of x. The square root of x can also be written as x 1 over 2. I hope we can agree. X 1 over 2. Okay, we're back. I just wanted to write it better, right? Plus 20, the 20 here. The cube root is the same as saying x 1 over 3. So the square root, which also has a 2 here, right? It's just 1 over. So it's the fraction form of that, the reciprocal of that. So, okay, perfect. Now we get to this. This is the same as saying 7x to the power of negative 1. Because this, right, is to the power of 1. Then when you make it stand on its own, right, you have to, whatever exponent it is, whether it's 1, 2, 3, whatever, you have to make it negative. But I'm still not happy because I'm seeing fractions. I hate fractions. So like we just said here, whatever exponent it is, you make it negative. So you can say x, right, negative 1 over 2 plus, right, 20x 1 over 3 minus 7x negative 1. Are we happy now? Yes, we are happy. All of the x's are standing on their own. There's no dividing, there's no multiplying. Everything is nice and easy to derive. Now let's derive that. Now we're deriving. The derivative with respect to x, hey, stop trying to be sexy with me. Anyway, the derivative with respect to x is x minus 1 over 2 plus 20 x 1 over 3 minus 7 x minus 1. There you go. Okay, everything we do it again on its own. The sum rule, d over dx, not to x 1 over 3 minus, right, d over dx. I'm just taking out the sign. You're allowed to do that, or let's just not do that because it'll cause confusion. Negative 7 x negative 1. So let's just add. We just always add. If it's negative, we just put the negative in the bracket. So here what do we have? We have 1 times negative a half, which is negative a half x, and then negative a half minus 1 is going to give us negative 3 over 2 plus, right, 20 times 1 over 3. It's going to give you 20 over 3, right? And then we have x 1 over 3 minus, right, This 1 over 3 is positive, by the way. 1 over 3 minus 1 will give you 2 over 3. You see? Negative 2 over 3, sorry. So here, this negative minus 1 is going to give you negative 3 over 2. And then here, 1 over 3 minus 1 is going to give you negative 2 over 3. Plus, right? This 7, notice something. This 7, right, negative 7 multiplied by negative 1 is positive 7. Hence I said plus, right? And then here, we're seeing it's going to be x negative 1 minus 1, which is negative 2. You are expected, you're not going to be penalized if you don't. You can put it in a proper form, like you did up there, but they don't give you a mark for putting this in the proper form. If you left it like this, you get all your marks. You don't need to put everything back in their roots and then put everything as fractions again and whatever. You don't need to do any of that. This is perfectly acceptable. So let's just, and this has been the rules of differentiation. So there you guys, there you go. Bye.